Hello and welcome to the Tillage Edge with me, Michael Hennessy. This is your regular update for all your tillage news and advice. Tillage farmers are always looking for an edge in producing crops with consistently high yields at a lower cost. Organic manures may be the missing part to help in both of these areas. Mark Plunkett, a soils and plant nutritional specialist in Teagasc, joins the Tillage Edge to talk about the benefits of organic manures for tillage farmers.
Absolutely, Michael. Organic manures are very beneficial for tillage soils, and we generally think about NP and K and sulfur, but carbon is actually another, I suppose, nutrient that we add when we apply organic manures, and it's very much related to the soil organic matter. If you take an application of farmyard manure, say for example, if we put out 25 tonnes to the hectare, which is about 10 tonnes to the acre, we're adding about 2.5 tonnes of actual carbon, and about 15% of that carbon, 15 to 20% of that carbon actually ends up in the soil. So we increase the soil carbon by about 500 kilos per hectare. If you take an application of maybe a liquid manure, something like say cattle slurry or pig slurry, you're adding a lot more water, you're adding less organic matter and less carbon. So again, you're adding about 0.6 of a tonne per hectare of carbon in say 25 cubic meters per hectare or 2,500 gallons per acre, and that's ending up somewhere around 60 kilos of carbon per hectare. So I suppose it's a very slow process, Michael, in terms of building that carbon or building that organic matter. It takes time with the liquid manures, the likes of our cattle slurries or our pig slurries, but the likes of farmyard manure or mushroom compost, you're adding a lot more carbon and you can build the organic matter or the soil carbon more rapidly.
Okay, and farmyard manures or any of those organic manures, I suppose, they have carbon and obviously P and K, you mentioned, and we might get to that in a little while, but they're probably doing other things as well. What are they doing, do you think, in terms of soil biology or maybe some of the other chemical properties in the soil?
Well, I suppose the big thing, like if you think about soil, there's chemical as in terms of NP and K, and then there's biology and structure. And by adding soil carbon or soil organic matter, we're actually feeding the biology, and it's increasing the amount of nutrient cycling, or it's increasing the soil stability, or it's a bit like the glue. It's like organic matter is like a soil glue, and it brings all the soil aggregates together. So there's a benefit there that you feed the soil, you feed the biology, and it's working for you in terms of soil structure, soil stability. It's making soils more resistant to soil compaction, and obviously then it's feeding. There's a nutrient pool in humus, like the soil organic matter is converted into humus in the soil, and it's a valuable reserve of things like nitrogen, sulfur, potassium, magnesium, and trace elements. And I suppose that gives soils more resilience on the nutrient front, say in dry years, or in terms of rooting or establishment, that you're creating a better environment for the seeds to root, to get going. The crop has more vigor, and also you're making the soils more resilient to, say, heavy machinery passing over. They'll take water easily. You know, the infiltration capacity of the soil is increased, and also soils are more resistant to erosion, because you have that glue that, you know, makes the aggregates more stable in the soil.
And when you're talking about that biology, Mark, is it bacteria and funguses and nematodes, or is it that kind of thing that people kind of think about when they think about bacteria, about the biology bit?
Well, you're feeding everything. Like you're feeding the biology, you're feeding the bacteria, the fungi, you're feeding the earthworms, you're feeding the little beetles. All that soil life are feeding. It's like putting food on the table for them at a readily accessible, you know, source of organic matter, and they churn that up in their little stomachs, and they produce, like worms produce soil castings, and, like, you know, it contains a very available form of major nutrients such as NP and K and trace elements. And I suppose that's the big benefit. That's, I suppose, the X factor that you bring to a soil by getting in organic manure. That'd be farmyard manure, pig slurry, cattle slurry, poultry manure. There's also a range of bio-based fertilizers there, Michael. You know, things like, there's a trial going on at the minute up in Arklow there on the Burks farm. It's the Nutri to Cycle project, where we're looking at a range of cattle slurry, poultry manures, and also bio-based products coming from sludges coming from the milk processing industry. And we're actually looking at the long-term effect of those nutrients on the soil in terms of soil carbon, soil structure. We're putting those out on a continuous basis over 4 years. We're in year 3 of the project. So that trial is going to yield, I suppose, very, very good results for tillage farmers on how to use these nutrients as effectively as possible, and also their benefits in terms of improving soil health and soil structure.
And for a farmer who might be applying organic manures for a while, how does the farmer know whether that's working or not in the soil?
Yeah, it's a very good question. But from talking to farmers, like, you hear the comment that the land is easier worked. You know what I mean? That there's less draft or there's less diesel required. That, soils plow up, they're more friable, they're more workable, they're more stable. You see an improvement in earthworm activity. The birds are coming down behind you when you're plowing. The soils are healthier. You're getting good crops. I suppose there's a bit of resilience in there. Like if you get the tough spring or the hot summer, that the soils have a better ability to supply both nutrients and moisture. And once they're managed correctly, there's a benefit. Like you're adding, especially the continuous tillage soils, you're adding carbon, you're adding organic matter, you're feeding the biology, which is improving the structure and which is improving the availability of the major nutrients during the growing season.
I heard a good soil scientist telling me one time that how do you know if it's working? And his answer was relatively simple. You get high yields consistently. I thought it was a very simple answer to perhaps, as you're saying yourself, is probably a more complex structures kind of going on in behind there.
Yeah, you're getting seasonal, you're getting consistent yields from year to year.
So Mark, where you have a farmer who has access to organic manures, where should that farmer prioritize applying those manures on the farm?
I suppose, again, I suppose a good place to maybe think about, which fields, maybe where have you seen yields dipping over the years? Has there been a fall off in grain yields? Maybe look at the soil test results, see which fields are index 1 and 2 for P's and K's. Also look at crops that have a big nutrient demand. Say, if, say a winter wheat crop. Also then the opportunity, Michael, when can you get that organic manure in? Like I think spring crops provide a good opportunity. Say like the spring barley, you can get in the springtime, you can plow it in, there's a window there to get those nutrients, and there's an opportunity to utilize the likes of, say, pig slurry, cattle slurry, poultry manures.
So Mark, what sort of level of P and K is actually in the likes of farmyard manure, say a ton of farmyard manure, or maybe 1,000 gallons of, say, good quality cattle slurry?
Okay, Michael, if you take a ton of farmyard manure, it contains about 3 units of nitrogen, 2 units of phosphorus, and 12 units of potassium. So a typical application rate there would be 10 tons per acre. So that would supply 30 units of nitrogen. It would supply 20 units of P and 120 units of potassium. If you take something like cattle slurry, good quality cattle slurry per 1,000 gallons, again, it contains 9 units of available nitrogen, 5 units of phosphorus, and 32 units of potassium. So again, an application rate of, say, 2,000 gallons to the acre would give you 18 units of nitrogen, 10 units of P, and 64 units of potassium. So that's a direct replacement, and that's what the research would have shown, Michael. Work done in Oak Park by Richie Hackett on pig slurry, that you can directly replace bag fertiliser in terms of NP and K, which, say, take 1,000 gallons of pig slurry is something like a 19,720. So that's the available NP and K. So you could replace somewhere in the region of about 30 to 40% of the crop's nitrogen requirement and about 50% of the crop's P and K requirement.
Okay, so that's quite substantial then, really. I mean, it's a valuable source of nutrients. But how, say in your slurry there, you talked about, is all slurry equal, or can a person measure the P and K values in slurries?
Yeah, again, that's a very good question, and I suppose one of the key things that we would have seen, the work that we've done over the years on both poultry manures and pig and cattle slurries, that it's very, very important to get an idea or to measure its NP and K value. So again, you can do it simply with some, like for the liquid slurries, some like a slurry hydrometer. You can do it on farm. It measures the dry matter of the liquid slurry, and you can estimate, or gives a very accurate estimate of its NPK value. For the solid manures, the likes of your poultry manures, your farmyard manures, your mushroom compost, again, I would encourage people to get them tested and trust the analysis, and that gives you information as regards how to use the nutrient effectively in terms of the application rate that you apply. You could supply, for example, up to maybe 50% of the crop's NPK requirements with, say, a poultry manure, for example, and then supply the other 50% with bag fertiliser. And again, you'll get the same results. Like, it's a direct replacement for the NPK and bag fertiliser that you apply in the organic manure, whether it's poultry manure, pig slurry, or cattle slurry.
And for the slurries, Mark, a farmer can use a hydrometer, which am I right in saying that measures the dry matter, of which you then can estimate the P's and K's? And
correct.
How long does that take? Does that take a half an hour, 2 hours? How long does that take for a farmer in a yard?
For pig slurry, it's instant. Like, you just get a cylinder, a litre cylinder container, get an agitated sample of pig slurry, and just gently drop the hydrometer down into the pig slurry, and it'll read off instantly, because the pig slurry tends to be 3-4% dry matter. The cattle slurry, you may have to dilute it, or if the cattle slurry is thick, if you just sit it into it and go off and have a cup of tea or a sandwich or whatever, and come back in maybe half an hour, 3/4 of an hour, it'll settle, and you'll get a reading then. As say, you'll get a reading in terms of dry matter, and there's a very close link or relationship between the dry matter and its actual NPK content. And like, a hydrometer costs about 50 euro, 50-60 euros. So you could have that on site to get an estimate of the actual manure. You could send a sample off to the lab for analysis. Again, it would be more accurate. So you've either option there, either to
Mark, tillage farmers, they can often find it very hard to get their hands on, I suppose, local sources of organic matter, and they can often have to transport it to their farm. So from an economic point of view, how far can tillage farmers transport this stuff in, for it to make sense, if you like?
I suppose, Michael, again, it's for the likes of pig slurry and cattle slurry, that tend to have a lot of liquid in them. It's very much, I suppose, investigating your local situation. Like, is there a readily available source of cattle slurry or pig slurry? And then I suppose it's meeting the pig farmer or the livestock farmer, and I suppose seeing how it can be done. Like, you can put a value on, if you take 1,000 gallons of cattle slurry, it's worth somewhere in the region of somewhere around 22 euros per 1,000 gallons. If you take 1,000 gallons of pig slurry, it's worth about 26 euros per 1,000 gallons. So again, I suppose you just have to do the maths in terms of distance. You're probably talking between 5 and 10 miles for the liquid manures. And I suppose, like, some piggeries, for example, may have a facility where they can maybe bring Arctic loads, maybe 5,000-6,000 gallons a go. And again, I suppose it's just seeing what's available in your locality. For the solid manures, the likes of your poultry manures, they're more nutrient dense. Like, if you take layer manure, like, it's coming out of a layer house and it's dried. So you have a product that's very, very dry, and it's very transportable. Like, you can transport it a longer distance than you can, say, for your liquid manures. The layer manure, say, it's very nutrient dense. If you take layer manure, like, it's something like a 23, 11, 24. It's worth about 35 euros a ton. So, you could put in a transport cost there of maybe 15, 16 euros a ton, and it still leaves it very, very attractive. You can bring it a long distance. So I suppose, in a nutshell, it's very much down to the type of manure and its nutrient density, or its nutrient content in terms of NP and K.
Okay. And for a tillage farmer who's bringing that material on, let's just say slurries, I suppose, are they required to spread it under the less method, or the non splash plate system, if you like, so using trailing hose or that kind of stuff?
Yeah, again, there has been, I suppose, a big conversion. There's a number of farmers after taking on the low emissions, like the band spreader and the trailing shoe, and it's the best way to utilize the nutrients. In terms of emissions, like you're going to reduce the nitrogen loss. It's also a more precise way of delivering that nutrients. You're going to get a more even application across the spread width. So yes, there is big benefits there in terms of using the low emission application techniques. And like I know a number of piggeries that have invested in that technology. So you're getting, I suppose, a better product. I mean, you're on a more precise applied product as well in terms of delivering NP and K for your cereal crop or your oilseed crop or maize crop, whatever crop you're putting it on.
And where a tillage farmer uses that technology for, the low emission spreading technologies, is it as crucial then that that material is ploughed down to try and trap that nitrogen that's in the slurries as quick as they can?
It probably takes the pressure off a little bit, but again, the sooner it's ploughed in, like, work done in Oak Park there, Richie Hackett done work a number of years ago on pig slurry, and like Richie would have band spread it at the time, from memory, and it was ploughed in. So the sooner, if you combine low emission spreading with ploughing, you know what I mean, you're retaining a lot of the, you're retaining the nitrogen. You're going to get 50% of the nitrogen as we have to achieve. So the figure that I gave you, that 1970, you'd be very confident that you had 19 units of nitrogen in that slurry. And I suppose the other one then to, I suppose, help you in determining how much nitrogen is in that is getting it tested or getting the slurry hydrometer or sending a sample off to the laboratory to see exactly what's in it and see how does it compare to the book value.
Mark, it's a fascinating area, and certainly there's a lot of potential benefits and also savings for tillage farmers out there by using organic manures. It's a topic that we could talk about for another hour if we wanted to, but we're going to have to leave it there. So I just want to thank you very much for your time, and we'll come back to you again and maybe have another chat about it maybe later in the year. Thanks,
okay,
Mark.
thank you.
That's it for the Tillage Edge this week, and my thanks to Mark for joining me on the podcast. You might like to join us at our events as part of the Teagasc Tillage Month over the next few weeks. We are running online spring seminars, the National Tillage Conference, and a number of winter crop management webinars, and also a malting barley conference over the coming weeks. For more information, look up teagasc.ie/tillage month. Don't forget, if you like this podcast, recommend it to a friend or colleague. And as always, rate, review, and subscribe on Apple Podcast or Spotify so you never miss an episode. And for more farming information, go to teagasc.ie. I'm Michael Hennessy. Thanks for listening, and I'll be back next week with more tillage news and advice.